So yeah, so this is going to be available for review. So Pythagorean theorem, first thing.
Oh, a squared plus b squared equals c.
Yeah, a squared plus b squared equals c squared. That's pretty straightforward. Okay, and c has to be which side?
The hypotenuse.
Hypotenuse. Okay, so just like we were doing before with trig, so while this did present a little bit of a challenge to some people when we did this before Christmas, we should be very used to now identifying which side is the hypotenuse first. So in each of these problems, I just go like, okay, there's my hypotenuse, there's my hypotenuse, there's my hypotenuse. So I know which one is going to be my C in each case. So that makes it much easier for me to set up my equation. Should be here. This is x squared plus 6 squared is 7 squared. This is 7 squared plus the square root of 26 squared equals x squared. Okay?
Does it matter if the a and b?
No. No. The a and b can be in either order. It doesn't matter. And then we just do the math of this. So x squared plus 25 is 256. Subtract the 25 from each side. X squared is 231. So x is the square root of 231, which I don't believe simplifies. I'm not sure if that simplifies or not. I don't think so. Here I get x squared plus 36 is 49. Subtract the 36. I get x squared is 13, so x is the square root of 13, which I know does not simplify. Okay? And here 49, and the square root of 26 squared is just 26, because square root and square root are inverse operations. Right? And if you're not sure, you get a calculator, you put in the square root of 26, hit the squared button, hit equals. It'll tell you 26.
On a test, would you help us with that?
No.
Why not?
I'll show you where the square root button is. I'm not going to do it for you.
Why not?
So 49, 26, that's going to be 60, 75.
I might have an extra.
X squared, so x is the square root of 75,
I might not. Okay.
which is 5 root 3.
Pencil. That's a little dinky.
I'll take some as I got.
Please do not be throwing them at each other. Okay, we talked about this on Thursday. All right, so those are our first three problems. Honestly, you know, everyone should have them set up properly. That should not be an issue at this point. You know, I can understand if there's a slight arithmetic error, but make sure that you are showing your work on even these simpler problems. Show your work, show your setup. So just in case you do make an arithmetic mistake here at some point, you come up with 221 instead of 231 here, you make some little silly subtraction error. You don't lose all your points. You need to show your work to get partial credit. Yeah.
Is it wrong if you do the wrong formula, but get the right answer?
What do you mean wrong formula? How would you do?
Or, not this one. Just saying like in general.
On certain problems, yes. Okay. So like if on the special triangles, the 30, 60, 90, 45, 45, 90, if you use trig to solve those, yeah, that would be incorrect. You have to solve those using special triangles. Okay? All right, acute, right, or obtuse. Again, this is still just Pythagorean theorem. Still just Pythagorean theorem. So, all we're doing is identifying what would be my longest side, which should be fairly obvious. This is the longest side here. This is the longest side here. And we're going to set up Pythagorean theorem, but we're not going to put an equal sign in there. We're going to leave a blank there because we're trying to determine if it's equal or not. If it's equal, then it is a right triangle. But if the long side is too big, then it's obtuse. If the long side is too short, then it's acute. So 14 squared plus 14 squared compared to 2√85 squared. That's 196 plus 196. And 2 times square root of 85 is 4 times 85, which is 320, 340. But this over here is 392. This is 340. That's way too small, so this is a cube.
I just don't like.
Where's that 360? 285 squared. What is that off top? Who did that? I think it's still a cube, but I may have. I was doing that in my head, which is probably not a really good idea. But I can't see where I put my calculator right now. Somebody get a calculator out. Check that for me. 285 squared.
No.
Guys,
170.
what is it?
170.
No, it's not.
Jesus.
I think it's 340. 2√85.
Is it because I don't have it in front of me?
Square root of 85.
Probably yes.
Where's the square root?
It's 340.
So I was right the first time.
Yeah.
Yep, okay.
Yeah.
Because I didn't.
Yep. Yeah, be careful when you're doing that in your calculator. If you just do 2√85 squared, plug it in all as one thing, remember, your calculator knows order of operations. It's going to do exponents before multiplication. So it's going to square the √85 before it multiplies it by 2. But we're looking really at the whole thing, 2√85 squared. So either you have to put it in parentheses, or you have to hit the equal sign after you do 2√85 and then hit the square button. Guys, stop. Masks up. Over the notes. Okay, Jordan. Okay, same thing here. 11 squared plus square root of 57 squared. Square root of 226 squared. This one I like because easy. This is 121 and 57. And this is 226. So clearly this is 178 and 226. That's way too big, so this is obtuse. All right. So that's the way that those guys work. All right, for these, we need our two special triangles, which we've talked about extensively. And basically, you just have to memorize their patterns.
These are the 3060, right?
Yeah, these are 45, 45, 90, and the 30, 60, 90. 45, 45, 90, the two legs are the same. Hypotenuse is the leg times the square root of 2. (30, 60, 90). You've got the short leg. The long leg is the short leg times the square root of 3. And the hypotenuse is simply 2 times the short leg. Double the short leg. Now, yes, it's a regular 2 here. And it's a square root of 2 here. That's something you definitely have to keep straight. Also, you have to keep straight which side is the hypotenuse and which side is the long leg in the 30, 60, 90. So, make sure we're doing that. By the way, folks, right now, we definitely do not need computer screens open. So let's close them up. All right? So, knowing these two patterns. Now, if you remember on the quizzes, and on the review here, I'm not giving you like the super hard ones that give you a hypotenuse of 5√7. I give you problems that are fairly straightforward to plug into this pattern. Basically, it's just checking, do you know the pattern or don't you? So here, look, I give you a 45, 45, 90. One of the legs is 2. It's a whole number. Couldn't be easier. Follow the pattern. This is 2. This is 2 root 2. Leg times the square root of 2. Okay? Should be like 3 points. Here, it's the hypotenuse, but the hypotenuse is 2 times the short leg. Well, 2 times what is 2? 2 times 1 is 2. So that's 1 times the square root of 3, or just the square root of 3. It's just knowing the patterns. Even here, this is a long leg, 3 times the square root of 3. Well, if I know my pattern, that's this short leg times the square root of 3. So the square root of 3 is there, the short leg part must be the 3. Which means this has to be 6. And again, 45, 45, 90, if this is 3, then this is 3, this is 3 root 2. So I'm not giving you difficult problems. There might be one that makes you do a little bit more of the math with it, but it's really just checking, do you know the basics? Do you know the patterns? And if you don't, then you better start memorizing them. We've only been working with them for, gosh, like 5, 6 weeks now. Patterns. So, make sure you know those patterns. All right, these are our 3 triangle problems, or our geometric mean problems. Okay? So these are the ones where we set up our 3 triangles and set up our proportions and cross multiply and solve. And I even set up that, I think I even in the review put the first one for you. I drew 3 triangles as kind of a reminder. I don't do that on the test. This is the mama bear, papa bear, baby bear situation. Each triangle we think of in terms of the short leg, the long leg, and the hypotenuse. So here in the outer triangle, big papa, short leg I don't know, long leg I don't know, hypotenuse is the whole thing, 36 plus x. That's not so nice, but oh well. Mama triangle, second triangle, the short leg is 48. The long leg is x. I do not know the hypotenuse. Baby triangle, short leg is 36. Long leg is 48. From that then, I have my matching pairs. This x goes with this 48. Okay, this 48 goes with this 36. So x over 48 equals 48 over 36. Cross multiply. 36x equals 48 squared. Again, whatever that is. There's my calculator.
Big number.
48 squared is 2304. Divide by 36 is 64. Okay. We could have also done this with the geometric mean method. The geometric mean method, remember this piece, we got 3 pieces here, all share this endpoint right here. So 48 is the square root of 36 times x. And we get the exact same equation when I square both sides. Faster, but you got to set it up just right or you're in trouble. So if you're not comfortable with that, then don't use that method. You are fine. And math, Silver knows this, guys. Okay. Second one. Again, geometric mean method here would be very fast because I got the 15 here, got the 9 here, and the x is the whole bit. So it would be 15 is the square root of 9x. Squaring both sides, I get 225 is 9x dividing by 9. 225 divided by 9 is 25. Or I could do the 3 triangle method. In this case, Big Papa triangle, short leg is 15. Long leg, I don't know, hypotenuse is X. And little baby triangle, not gonna use mama this time, because don't know anything about mama.
Okay.
Little baby triangle, short leg is 9, hypotenuse is 15. So X over 15 equals 15 over 9. Or 15 squared is 9x, 225 is 9x. You
So
get the same.
why did you square the one on the bottom?
What, this one?
Yeah.
Because that's if you're not good with the geometric mean method of solving that we talked about, then don't worry about it, then don't even try that. Okay? There are two different methods we can use to solve this. If you're looking at this going, I don't get how you got those numbers, then don't even try that. Okay? Just for people who did kind of work with that method, I put it up there. But don't, at this point, just do the 3 triangles. Okay?
Little triangles, right?
It's just a different way of setting it up. It's fast, but if you don't get it, it's not gonna work out well. Again, more practice of the same thing. If I set up my 3 triangles, I can see for Big Papa on the outside here that short leg is 60, the hypotenuse is X, I don't know the long leg. And Mama, I'm not gonna know anything about, so I'm going straight to baby. Short leg is 36, hypotenuse is 60, so X over 60 equals 60 over 36. So when I cross multiply, that gives me 36x equals 3600, so X is 100. That one actually works out really easy, don't need a calculator for that. For this one, setting up my triangles, okay. Papa triangle on the outside I'm not going to know much about, but Mama I'm good with. Mama has a short side of leg of 12 and a medium leg of 16. Baby triangle over here, short leg of X, long leg of 12. So 16 over 12 is 12 over X. So 16x is 144. When I cross multiply, and what is that, 8? 144 divided by 16? Hold on. Sorry, it's 9. Push me.
You just left it.
Okay. So X is 9. So again, knowing how to set those up, they're pretty mechanical. And if you take the time to draw out your triangles and just are careful about short leg, long leg, hypotenuse, and labeling and getting the right number with the right thing, the proportions kind of solve themselves. Okay. Guys, masks, over noses, leave them there. Okay. They shouldn't be falling down on you while you're sitting still. Alright? Geometric mean between two numbers 3, 4, and 9. How do I find a geometric mean?
Strike. Did we use the SOHCAHTOA?
No.
Gotta use
Nothing to do with trig.
this is a different question. I thought we were on 15. My fault.
This has nothing to do with trade.
Geometric mean between 4 and 9. Yeah, nothing to do with trig.
Yeah, man, I don't know what it is.
How do I find a geometric mean between two numbers?
You got it. You find the average.
Multiply them and take the square root. Yeah. It's not average. Okay, you have to give arithmetic mean as average, where you n divide by 2.
That's when you gotta
Geometric mean
multiply.
is you multiply and take the square root. So square root of 4 times 9, which is the square root of 36, which is 6. So there's to it. You multiply and take the square root. Very simple process. And you have to remember how to do that. All right, now we jump into the things that you're pretty strong with. SOHCAHTOA.
Yeah, I do. I love SOHCAHTOA.
Okay, most of you did pretty well with this stuff. So again, very much like the quiz we just took, about a week ago, not even a week ago, we took this quiz. Most of you did very well on it. Same thing. All I want is sine of z. I don't want to figure out what angle z is. I just want to know what find the value of the ratio. Read the question, please.
14 and 15.
Okay? So sine is opposite over hypotenuse. Angle z is my perspective, so this is my opposite. This is my adjacent. This is my hypotenuse. Opposite of hypotenuse would be 14 over 50, which we should reduce 7 over 25. Tangent of C, again, same thing. There's my perspective, opposite, hypotenuse, adjacent. Tangent is opposite over adjacent, so 8 over 15. And it doesn't even reduce. Okay? Those are very simple as long as you can identify the sides. Now, where people have been messing up on this, on the quizzes, which is not often. You guys did very well on this overall in the quiz, but people who did make mistakes, where they made mistakes is they misidentified the sides. Switching up the opposite adjacent most commonly, which tells me that you're looking at the wrong angle. In most cases. It's pretty obvious. I mean, you know, I don't mean to be dismissive, but if this is my angle, which side is opposite? Okay? It's not 15. 15 is not opposite of angle C. If you understand what the word opposite means, on the other side, it's pretty easy to see. Okay? So if you slow down and just take a moment, you'll be fine. And most of you, like I said, did very well on this quiz. Most of you got A's and B's on it, so not that worried. Same thing here, sine of Z. Again, Z is my thing. Opposite, hypotenuse, adjacent. Sine is opposite of hypotenuse, so it's 21 over 35, which does reduce. 7 goes into both of those. And cosine of Z, again, identify your sides. Opposite, adjacent, hypotenuse. Cosine adjacent over hypotenuse. 18 over 30. 6 goes into both of those, so 3 out of 5. Okay? And again, we are not finding the measure of the angle. We aren't using our calculator at all for those problems. We're just finding the ratio. So don't overthink those. Now find the missing side. If it's find the missing side or find the missing angle, now we're going to use our calculator. We're going to have to set up our trig equation, and we're going to have to solve it. Now remember, when we set up our trig equation, it's always function, sine, cosine, or tangent, of the angle equals, sorry, I got the fat one in there, equals the ratio. Okay? And the unknown could be the angle, it could be the numerator of the ratio, or the denominator of the ratio. Okay? My unknown could be in any of those places. If my unknown is the numerator or denominator of the ratio, I'm going to just use my regular function, sine, cosine, or tangent. If my unknown is the angle, I'm going to use the inverse function. Because we use the inverse function to find an unknown angle. So in this case, again, we start out exactly the same way as we have. This is 24. This is clearly my angle that we're working with. Opposite, hypotenuse, adjacent. First thing I have to do is decide which function is the right function to use. Sine, cosine, or tangent. What will it be here? Cosine, because it's adjacent hypotenuse. So I set up my equation. Cosine of 24 is 18 over x. When the x is in the denominator, we wind up swapping these two. So x equals 18 divided by cos 24. Pop that in the old calculator. $19.7. Which makes sense because it has to be longer than this side here. Okay? For this one, the process is so repetitive, we just keep doing it. Opposite, hypotenuse, adjacent. This time opposite and adjacent are in place, so we will use tangent. Because tangent is opposite over adjacent. Tangent of the angle equals the opposite over the adjacent. How are we going to solve that one? Going to multiply both sides by 11 to cancel out the denominator. Give me x equals 25.9. Okay. So, very much we just keep on doing. This one. Angles here, opposite, hypotenuse, adjacent. This is adjacent hypotenuse, so which function? Which one are we going to use here? Sine, cosine, or tangent? Cosine. Cosine of the angle equals the adjacent or the hypotenuse, so x equals 10 divided by cos 71. $30.7. Again, here's my angle, opposite, hypotenuse, adjacent. Opposite and adjacent here, so what function? Tangent. Tangent of 63 is opposite over adjacent. Multiply both sides by 17. And calculator 17 tan 63. 33.4. Okay, I think those are fairly straightforward, and you guys, like I say, overall have done very well with them. So I'm not too concerned about that. Same situation, find the measure of the angle. Now this one's a little bit tricky because I know all the sides. Okay, so since I know all the sides, I can pick which function I want to choose. This is my angle, this is my opposite, hypotenuse, and adjacent. So honestly, I could use any function here because I know all three sides. I just have to pick one. Which one would you like to pick?
Tan.
Tan, okay. So tangent of x equals opposite over adjacent, 39 over 52. I don't have to worry about reducing that. That's fine. How am I going to solve that? Since the angle is unknown, I'm going to use the inverse, yeah. So tangent inverse of 39 over 52 equals the angle. So tan inverse 39 divided by 52. 36.9 degrees. Okay. Same here. Identify my sides. Opposite, hypotenuse, adjacent. If you have all three, if you've got a method that works for you, fine. It doesn't have to be tangent. It could be sine. Sine of x is opposite over hypotenuse. 57 over 95. So I'm going to use the inverse function to find the angle. So again, second function sine, 57 divided by 95. Make sure you put the right numbers in your calculator, because if you don't put the right numbers in, you're going to get
Wrong answer.
bad answers. Exact same angle. How about that? Okay.
That's the one that was wrong.
Oh, okay. A hiker leaves base camp. Yay! Always love the story problems. Hiker leaves base camp.
37, dude.
Goes 5 miles due north and 12 miles due east. How far is the hiker from base camp by the end of the day? It's not 17 miles. Okay. Draw a picture. Base camp. Due north 5. Due east 12. Right triangle. on the third side. Do I need trig for this? No, this is Pythagorean theorem.
Eighth grade was easy.
25 plus 144 is 169 is x squared, so x is 13. And a lot of people might have recognized that wonderful Pythagorean triple 5, 12, 13 and spared yourself some time writing the equation. Okay? When you get a story problem, use the method that makes the most sense for that particular problem. It might be trig, it could be Pythagorean theorem, it could be a lot of different things. That's where we draw the picture first. Guys, noses in. I'm not telling you again.
Can I go to that?
Can't wait, yeah.
Okay. Oh, you forgot to square root it.
Okay? I did. Put time on to it.
Oh, my fault. Look at the E, I was confused.
A mountain road gains 800 feet of elevation in 2,460 feet. What is the average angle of elevation? Okay? That's still worth looking at. Okay? So the elevation change is 800 feet. The road is 2,460 feet. What is the angle of elevation? That's going to be a trig problem, isn't it?
Yeah.
Okay? Identifying our sides. This is the opposite. Hypotenuse adjacent. So I'm going to use sine here. This opposite hypotenuse. Sine of x is 800 over 2460. Since the angle is unknown, we use the inverse function. So, second function sine, 800, ooh, wrong number. 800 divided by 2460. About 19 degrees. That is an extremely steep road. Okay, 19 degree at 19% average gradient. That's pretty steep. Another one like this, you need to find the height of a tree. Since you can't measure it directly, you walk 30 feet from the ground level to measure the angle of elevation at the top of the tree at 74 degrees. How tall to the nearest tenth of a foot is the tree? Again, draw a picture. Tree, 30 feet out. Height of the tree unknown. Angle, 74 degrees. Angle of elevation or angle of depression is always taken from the horizontal perspective. Okay, so from the horizontal line, that's how we find our angle of elevation or angle of depression. Never from the vertical, always from the horizontal mark. And then we set up. Again, trig problem. It's our opposite side, hypotenuse adjacent. This is opposite adjacent, so that's going to be what function?
So, tan.
Tan.
Is there something to that?
So tangent of 74 is x over 30, so x equals 30 times tan 74. Multiplying both sides by 30 because x is in the numerator. So 30 tan 74 gives me 104.6 feet. An 18-foot ladder is leaning against a 16-foot wall with the top of the ladder at the top of the wall. What is the angle of elevation of the ladder to the ground? Again, draw a picture. Wall, ladder. Ladder is 18 feet, wall is 16 feet. What is the angle of elevation?
I always think that's 45 right there. Every time you have that little thing. I
Yeah,
think
it's just
45
measure marking an angle. It doesn't mean it's 45. But we have opposite, hypotenuse, adjacent again. So this is going to be a sine of x is 16 over 18. And we're getting repetitive now. Sine inverse of 16/18 equals x. So we use our inverse function, 62.7 Okay. And again, that's the kind of thing that, you know, if you're doing your OSHA safety standards, and you don't want your ladder to be greater than a 70-degree angle, that's, you're just fine with that ladder. Okay. All right, then we get into law of sines and cosines problems. Now, again, you are going to have a run off. You will be given a formula sheet tomorrow that has the area formulas, the law of cosines in it, and the law of sines in it. Okay? So you do not have to have these last formulas memorized. They are given to you. You do have to know how to use them. So, the other thing you'll notice is, unlike in the homework, we had to solve all the angles and all the parts of the triangle. With these, it's just one. Just one is sufficient. So find the measure of angle A. So, again, using our law of sines, we're going to say the sine of A, since that's my unknown, I'm putting that first. That'll be over side A, equals the sine of B, which is 96, over side B. Okay? C is not even involved. This is not a SOHCAHTOA problem, because it's not a 90-degree angle. And it says, use the law of sines, or cosines, in this case it'd be sines.
Isn't the sine one easier?
I think so.
Because like you just have to do like multiply it.
Yeah,
by-
now we cross multiply, yeah.
What's the one where we have to like divide it by 2 and multiply it? Something like that.
I'm not sure what we're talking about right now, we'll get there. Okay? Cross multiply, divide by 10 to get sine A by itself. So 5, 9, sine 96 divided by 10. Remember the equal sign after the numerator. Gives me 0.4972. And then we do the since it's an unknown angle, just like we did. I mean, honestly, just like here, it was an unknown angle. When the angle's unknown, we use the inverse function. So second function sine of that number tells you it's about 29.8 degrees. So inverse sine of 0.4973 is 29.8. Okay. Find AC. Now this is a side angle side situation. Law of sines is not going to apply. This is going to be a law of cosine situation. So we're looking for side B here because this is angle B. This is side B. So the formula I'm choosing is the one is B squared equals A squared plus C squared minus 2AC cosine of angle B. Because I want to know B. Side AC is the same as side B. So my sides are 29 and 28. My angle is 92.
Wait, is this the one? Just talking about?
Maybe.
Actually, I don't know.
So I take 29 squared, and this one's easy to put in my calculator. 29 squared plus 28 squared minus 2 times 29 times 28 times cosine 92. That gives me 1,681.67. Okay? 6/8 if I round it. But that's not B, that's not my side, that doesn't make sense. I need to square root of that. So it says about 41 almost exact, 41.0. .008 to be exact, 41.0. To the nearest tenth. I think there's an area problem on the test too. So let's find the area of this triangle at the same time.
This might be what I was talking about.
Okay, the area is 1/2
Yes.
times 29
Yeah, that's what I was
times
talking
28
about.
times the sine of 92. The
That's
area
exactly
formula
what
uses the sine. So 29 times 28 times sine 92. 405.75. 405.8 is my area. And that pretty much wraps it up. I mean, that's everything that's going to be on there. Now, it is going to be a Schoology test. It's going to be online. Okay? But I'm going to expect that you are going to be turning in all of your work with it. So make sure you have tomorrow something to write with. Don't come here and ask me tomorrow, do you have a pen or a pencil I can borrow? Bring it with you. Bring your calculator. Bring your computer and make sure it's charged. Now, if you don't have a calculator, I did enable on the test the calculator that's on Schoology that will pop up within your test. But your handheld one's going to work a lot better for you, so don't rely on that. Bring a calculator with you. If you don't have one, borrow one. Don't sit there and try to do this test without a calculator. It is not possible. Okay?
How do you know?
All right. You can use the rest of the time that we have here, which is, we still got, what? We're here till 43, so we still have almost 20 minutes. Now,